Hi everyone, let's get started. So we're gonna start talking about biochemistry stuff. So the last set of videos I was mentioning how a lot of this stuff I thought was more for testing material, just to get you introduced to new vocab and stuff. From here on out, we're gonna use all of this for the rest of the semester and year. So it is important to start learning this stuff as well as you can. Okay. So let's start with biochemistry. His definition is the chemical composition and reactions of living matter. And that kind of makes sense because you have bio and chemistry. So we have life and we have chemicals. So chemical composition and reactions of living matter. So let's separate these between organic and inorganic compounds and see some differences. So when you think of organic, what's the first thing that comes to your head? The first thing whenever you typically learn organic is that it contains carbon. So the things that we're going to be looking on and focusing on that are organic molecules are carbohydrates, lipids, proteins, and nucleic acids. So these are all going to contain carbon somewhere in them. And let's see how these how these are different than inorganic. So what do we have for inorganic? We have water, salts, acids, and bases. So we need to first go over this difference between the term dissolve and dissociate. But first let's get these up. Water, salt, acid, and a base. So this idea of dissolving versus dissociating. Here's a glass of water. And let's do dissolve for this one. So we're going to dissolve an organic molecule, an organic compound. So we're going to do a carbohydrate like sugar. So if we have, let's do purple. Let's say this is our big sugar cube. Well, the sugar cube is made up of a bunch of tiny sugar cubes. Okay, you get the point. A bunch of different tiny little crystals of sugar. Well, when you put these up, or when you put this in water, all of these little circles are going to break up, but they're still all little sugar molecules. So let's say, for example, instead of table sugar, this is glucose. So the chemical formula is C6H12O6. This is just a ton of molecules of C6H12O6. So that's a molecule of C6H12O6, that's a molecule of glucose, that's a molecule of glucose. So when you put it into water, it dissolves, meaning it keeps its same chemical structure. It doesn't change its shape. It just breaks up into individual subunits of whatever this big molecule is, or whatever this big group of the same molecules are. So that's dissolving. You don't break this apart. That's the big thing. This stays the same. It's just its physical dimensions shrink into this from this large sugar cube into these individual little small subunits of glucose. Now dissociating is different. So for dissociating, we're going to do salt. That's the easiest one, NaCl. So here's our salt cube this time. And I'm going to do it a little bit bigger squares just to make this easier on us. So if this is a salt molecule, then this is NaCl, this is NaCl, NaCl. With these salts, when you put them into a solution, so now it's going into our water, first it's going to break up into these. If you want to think of it in a two-step process, you have a smaller NaCl, you'd have a smaller NaCl, and this would be dissolving, right? But these dissociate. So what that means is that these individual parts of this single unit of salt are going to separate. So now if I had my NaCl molecule, it's going to turn into, or dissociate into, ions. So a positive ion and a negative ion. So dissociation of a molecule leads to ionization. Dissociation leads to ionization. These ions carry electrical charges, and we can use these electrical charges to make different electrical gradients throughout the body to cause different things to happen. So this is a super important thing to established from the beginning. Organic compounds dissolve in solution. This inorganic salt, as well as acids and bases, these are going to be dissociate into ions. Okay. So, and again, once we have these called, instead of ions, we can call them, we can call them ions, or we can call them electrolytes in the body. So salts, acids, and bases will all dissociate when put into solution like water, and when they dissociate into individual ions that carry electrical charges that we can use to create electrical gradients to do things within the body that we'll get into throughout the semester. Alright, so now we're going to get further into each of these, but I just wanted to separate them first and differentiate dissociation versus dissolving. So one more recap: organic compounds, they have carbon. Our main organic compounds we're going to talk about in our body are carbs, lipids, proteins, and nucleic acids. They dissolve, they don't dissociate in water. Inorganic compounds include water, salts, acids, and bases. Salts, acids, and bases will all dissociate, meaning ionize, go into their individual ions. When put in water, that creates electrical gradients that we can use to do things throughout the body.